forward. What the heck? There. Okay. I think we're good. Okay, so let's begin today. So we're going to start with chapter 12. Today we'll do 12:1 through 12:3. So last time you had an exam. The exams are all graded now, so so your exam score is updated. What else? In a week and a half, on the 28th, you have the chapter 12 project is due. And so that's in Canvas. So maybe I'll bring that up real quick. Okay, and so when you click on it, all the instructions are there. Let me quickly go over how to do that. Okay, so most all of the assignment that's due in a week and a half, we'll have gone through all of the notes tonight that will make it so that you're able to do that assignment. So you should have all the information needed for that after tonight's lecture. If we go down to chapter 12 here, it says take home exam. Okay, chapter 12, take home exam. Okay, and I click on that, and it says, please submit your worked out solutions as a PDF file. Okay, so here's the file itself. Okay, looks just like this. Okay, and it says it's due Thursday at the start of class. Okay, and then here's the questions and some graphs, and calculate the correlation coefficient. Okay, and the regression line, and then that's about it. So what a lot of students do is they'll print this off, and then they can work on it, and then take a picture of that and convert that picture to a PDF file, or they can scan it as a PDF. I prefer it as a PDF. So it says, please submit your worked out solutions as a PDF file. All exams are to be scanned, oriented vertically, and all pages submitted sequentially, that is in order, and uploaded no later than 6 p.m. Thursday, May 28th. Okay. Okay. So again, you should have all the information you need to do this assignment after tonight's lecture. Okay. Okay. I just wanted to make note of that. Okay, so we're going to talk about correlation tonight. Okay, so first thing that we're going to want to do is be able to create and interpret a scatter plot. Okay, be able to describe scatter plots and correlation. Okay, and we're going to define what a correlation coefficient is, and use technology to calculate the correlation coefficient between two variables. So use technology, okay, to calculate. Okay, build intuition of a correlation coefficients, should be of correlation coefficients and scatter plots. Okay. Okay, so is there a relationship in the amount of fat in a McDonald's sandwich and the total calories it contains? So is there a relationship here? Well, we could graph this. Zoom this down a little bit so we get the full screen there. Okay, we could graph this and see, running these numbers. Okay, the grams of fat as the x-axis is the x-axis, and the calories as the y-axis. Does the amount of calories increase as the grams of fat increases? Is there a positive relationship? Is there a negative relationship? Is there no relationship? Okay, so we want to see that. So the easiest way to do this is to start plotting points. Okay, so let's plot this graph. Okay, 9 to 60. So I'm going to get rid of the points real quick. Hopefully you have them in front of you. Okay, so 9 to 60. Okay, we're going to be about here. Okay, 13,320. 13,320 is going to be about there. Okay, 21,420. 21,420 is going to be about there. Each of these divisions is 25. So keep that in mind. Okay, each of the y divisions is 25, and each of the x divisions is 1 gram of fat. Okay, versus 25 calories. Okay, and then for the quarter pounder with cheese, 30 and 530. 30 and 530. So 30 and 530. About there. Okay, and we can already see that there looks like there's a relationship here, that as the grams of fat increases, the calories increase accordingly. Okay, and it's almost a straight linear trend at this point. Okay, linear meaning a line trend. Okay, okay. So let's do a few of these, a few more of these. 31 is 560, 31 is 550. So at 31, we're getting both 560 and 550. Okay, so 31 is a 550 and a 560. Oh, oops, that should be higher. 550 is here and 560 right above it. Okay, what else we getting? 34, 590, 34, 590. I think that's the largest one that we have. Okay, crispy chicken, 25 and 500, 25 and 500. About right there. And the fish fillet, the Filet-O-Fish, is 28, 560, 28, 560. 560 is about here. Okay, and grilled chicken 20 and 440, 20 and 440. Okay, is about here, we'll say. And is it 20 or 21? This one should have been 21. There we go. Okay, and what's the last one? The grilled chicken light has 5 grams of fat and has only 300 calories. That's kind of like the anomaly here. Okay. Okay, it doesn't follow the trend, but kind of bucks the trend there. Okay, and we could think of this as a trend. We could say, hey, you know what, there may be a trend line here. Now, I don't know exactly where this line is. That's going to be for us to figure out. We're going to use the calculator to figure this out for all of these values, and we'll get to that in 12.3. But we could kind of eyeball and see, you know, that there is a definite relationship here between the x and the y. Okay, and maybe the line looks something like that. Okay, I don't know. Okay, but again, we're going to get, eventually the goal is to get a line y equals mx plus b, and this is called the line of best fit, or the regression line. Okay, that's the goal here, and we use other letters other than m. We let m be a. So y equals ax plus b. Okay, for whatever reason they didn't like m, they want to use a. Okay, so ax plus b. Boom, that's it. Okay. 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 What happens to the number of calories as the number of grams increases? Well, it seems that the number of calories also increases, right? Number of calories also increases. Okay, if McDonald's introduced another sandwich that had 19 grams of fat, 19 grams of fat, estimate how many calories you would expect the sandwich to have. So 19 grams of fat, if we go back to our thing here, let's estimate 19. Okay, so where's 19? 19 grams of fat, okay, is like maybe around 425. 19 grams of fat, 425. Sure, sounds good. Okay. This one should be a lot higher than that. No, that should be right there. It's fine. It's 20. 20 was for, oh, 20 was 440, not 420. Whatever. Okay. So we'd say, yeah, around maybe 425 calories. Okay. 19 grams of fat, around 425, 425 calories. Okay. So something like that on that linear trend. Okay. It's a linear, it's a line of best fit, or a regression line is a linear trend. Okay. And the slope of this line is related to something that we're going to call regression or correlation. Okay, regression or also correlation. Okay, how much do X and Y correlate to each other? Okay, how much do X and Y correlate or relate to each other? Okay, how much do they relate to each other? Do they relate a lot, or do they relate a little bit? Okay, so we'll see. Okay, this they relate a lot. That's a pretty linear trend. Okay, now some of the trends are not going to be so nice and linear. Okay, when two variables are associated, okay, again, think X is associated to Y. When two variables are associated, then there's a relationship exists. Then there is a relationship that exists. Okay, males are associated with shorter hair. Females are associated with longer hair. Doesn't mean necessarily that that's the case. Okay, that just is a trend. It's an association. To use the word correlation, okay, both variables must be quantitative. Okay, it must be numerical values. Okay, so you can describe the relationship numerically. Example, shoe size is associated with foot length. That's how you measure your foot length, is a certain shoe size. Okay. They have a blank correlation, and what goes in the blank here is a positive correlation. As shoe size goes up, or we should say foot size, as foot size goes up, as foot length goes up, well, what happens to shoe size? Well, it also goes up. Okay, as foot length goes up, shoe size also goes up. Okay, the more hours a person exercises each day, the lower their heart rate. They have this is negative. So positive is a positive trend. Okay, as foot length goes up, shoe size goes up. Positive, positive. That gives me a positive slope. Positive slope. Okay, so the slope, okay, is going to be directly related to the correlation. Positive slope, positive correlation. Okay, the more hours a person exercises each day, the lower their heart rate. Okay, they have a negative correlation here, negative. Now, why is that a negative? Because the more a person exercises, so exercise is going to be my, okay, so exercises, the lower their heart rate. So this will be exercise. How do you spell exercise? There it is, exercise. Yeah, I did it right. okay, exercise, and this is going to be heart rate, right? So exercise versus heart rate. And so say that you don't do any exercise, zero exercise, your heart rate would probably be, I don't know, around 80 beats per minute, I would think. So 80. Now, if you're a really good athlete, then maybe you could get your heart rate down to, I don't know, 50 beats per minute. Okay, you're obviously not going to be able to get it down to zero because then you'd be dead. And that would not be good. That would not be healthy. Okay, so we don't need any dead athletes. Okay, so this is a negative trend. Why? Because as I go over in the positive direction, as I go over in the positive direction, I'm going down in the negative. So over positive, down negative, and so the slope here. Okay, so as exercise as exercise increases, heart rate decreases, right? So it's an opposite relationship. We call this an inverse relationship. Okay, it's inverse. As one goes up, the other goes down. Okay, and so if it's a negative correlation, then it's a negative slope. Okay, so the slope of this line, okay, the slope of this line is negative slope. Okay, so here's positive slope for this guy here. Okay, positive over positive, negative over positive. Okay. Okay, downhill trend. Okay, compare latitude with mean January temperature. Okay, latitude with January temperature. Okay, what does each dot on the scatter plot represent? Well, it represents a specific latitude and its January temperature. Okay, so it's a specific latitude and its January temperature. So, okay, it seems that the higher I go up in latitude, the lower the temperature goes, right? So what's a latitude? Well, latitude is one of these circles on the Earth, okay, on the globe. If we're at 0 latitude, then that means we're at the equator. So 0 latitude, the January temperature is going, the temperature is going to be the same all year long. Okay, it's going to be a nice 70 some odd degrees, maybe 68 degrees all year long. Okay, with a little bit of variation, but not much. Okay, but you get way up here, okay, 45 degrees latitude. Okay, this is 0 degrees latitude. So way up here, you're getting cold, very cold, close to the Arctic Circle. So, okay, that makes sense. So this would be a negative correlation. Okay, negative correlation, and there's obviously some sort of trend here. Okay, a linear trend down. Okay, so what direction are the points going? What direction are the points going? They're going downhill. Downhill. Okay. Downhill from left to right. Okay, downhill from left to right. Okay, the lower the latitude, okay, the higher the temperature. Okay, so let's talk about this association. Okay, We always describe the association seen by discussing three features of a scatter plot: the strength, the direction, and the shape. Okay, the strength, the direction, and the shape. The strength, we use strongs like strong, moderately strong, or weak. Okay. Okay, direction, we use words like positive or negative. Okay, because again, you're thinking of this in terms of a line. Okay, and the shape, is it linear or is it non-linear? Is it a line or is it something other than a line? Quadratic is a U shape. Exponential is kind of half a U. Okay, it curves up. And then logarithmic, it curves the other way. Okay, etc. Okay, if you're getting curviness, definite curviness, then it's not linear. You know, this course, we don't care about the non-linear ones. We call it linear or non-linear. We're not going to spend too much time on non-linear ones. That's an advanced technique to try and find the association for non-linear ones. We're just going to say, hey, that's not linear. It's weird. We don't care about it, and we're going to move on. Okay, so let's try to talk about the characteristics of the scatter plots that we see. Okay, so is there a correlation between the x and the y's for this first example here? Okay, so for the first example in blue here. Okay, and this kind of seems like a shotgun blast. Okay, the x's and y's, we have really small x's and small y's. We have some big x's, small x's and small y's. We have some big x's and big y's, but we also have some big, medium x's, or big x's and small y's. And then over here, we have some kind of small x's and bigger y's. So there does seem to be a trend, but I would say that it's a weak linear trend. Okay, it seems to be positive. Okay, so it's a weak positive linear trend. Okay, or correlation. Okay, so weak positive linear correlation for this one here. Okay, let's look at the one below it. This definitely has a linear correlation. Okay. Okay. So this is going to be a strong positive, okay, linear correlation. Okay, that's a strong positive correlation. Okay, what about the one below it? The one below it is even more of a shotgun blast. Look, we've got low x's and low y's, but we also have low x's and high y's. We have low high x's and low y's. We also have high x's and high y's. It seems like they're just kind of random. So we say that there is no correlation here. Okay, it's not weak, it's not strong, there's just nothing. There's no correlation. It's not linear, it's just nothing. Okay. Okay, what about the next one here? This one right here. Okay, looks like we've got a linear trend. What type of linear trend is that? Well, I would say that it's a moderate, okay, or maybe even a strong. We'll go with a strong. I can see definitely strong, a trend downward there. Strong, a negative linear correlation. Okay, strong negative linear correlation. Okay, what about this one? This one, is this linear? No, I wouldn't say that it's linear. I would say that it's curved. Okay, it seems to be a curved. I would say that this is kind of a weak nonlinear, it's positive because it's going uphill. Weak positive nonlinear correlation. Okay, we've got two more here. Okay, so if we have this U, that's a parabolic shape. It's extremely strong. Okay, so strong again, and this will just be, it's neither positive nor negative because it's curved. So it's a strong non-linear. Okay, strong non-linear correlation there. Okay, what about the one next to it here? Okay, we'll call this, I don't know, 6 and 7. Okay, what about the next one here? Well, this is again kind of a shotgun blast. Okay, there does seem to be a linear trend, but the slope is 0. And if we have a slope equaling 0, then we just say that there is a very weak, extremely weak. It's about the weakest you can get. It's a very weak linear, and it's neither positive nor negative. So very weak. I'm not even going to put linear on that one. I'm just going to put, it's just weak. It's I'll just put no association on this one, no correlation, because I mean I could put a line through this one too, and it does me absolutely no good. Okay, there's no real association there. Okay, no correlation. Okay, blah blah blah. Okay, let's talk about the correlation coefficient. Okay, R, correlation coefficient, and this is a measurement of how strong or how weak, okay, the relationship is for linear. This only works for linear. Okay, this is for linear associations. Okay, linear correlations. Okay, and then this is how it's computed. I'm not going to get into the computation. I'm going to let the calculator handle that for me. Okay, and it says the closer R is to 1 or -1, the stronger the relationship. So if we look back up here, where we have a strong relationship, R is going to be very close. R, which we're calling our correlation coefficient, is going to be very close to 1. Maybe it's like 0.98. Very close to 1 there, and it's positive. Okay. Now, this one here, above it, this would have maybe R value of 0.38. It's still a positive relationship. It's just not very strong. Okay, the correlation coefficient is closer to 0 than it is to 1. If it's close to 0, there's no correlation. For example, this has R equals 0. Correlation coefficient of 0. Why 0? Because there's no association there. And there's no slope. No slope, no association. The correlation coefficient is directly related to slope. Okay, it's directly related to the slope of the line. Okay, very strong slope. Okay, they're very close to 1. Okay, that's what we're looking for. Okay, strong negative slope. This is going to be like negative 0.87. Okay, R is equal to negative 0.87. Boom, that's a strong negative correlation. These we cannot do correlations on. Again, this would be R equals 0 down here. For the one with no correlation, we can't do them on nonlinear ones. Correlation coefficients don't exist for nonlinear associations. Okay. R equals 0 implies no association. Okay. Okay, scaling units do not affect R. It is unaffected by which is X and which is Y. You can flip it upside down. Okay, we only use linear associations with no outliers. Okay, only use, okay, and R is a statistic. Okay, R is a statistic. Okay. Okay. Okay, let's before we move on to 12.3, let's go back to our graph of the McDonald's people. Okay. Okay, and I'm gonna show you how to get the line of best fit, or let's just not get the line of best fit. Let's get the correlation coefficient. Let's get what R is. R is equal to what for this? Sorry, can everybody hear me? Yeah. Okay. For this data here, for the McDonald's sandwiches, let's figure out what R is using the calculator. Okay, maybe we'll do through StatCrunch as well. Okay. Okay, so I'm gonna put in my X values and my Y values. Now make sure you know which one's X and which one's Y. So I'm gonna put those into my two lists. So I'm gonna go to edit, go to stat and edit. I'm gonna clear these out, clear these guys, clear these guys, boom, okay. Okay, and I'm gonna go to, okay, I'm gonna go to L1 and I'm gonna put in my data for L1. This is gonna be the grams of fat, 9, 13, 21, 30, 31, 31, 34, 25, 28, 20, and 5. That's kind of an outlier. We'll leave it there. We'll leave it there. I mean, I'd probably throw him out, but we're good. Okay, let's do 260, 320, 420, 530, 560, 550, 590. Oops, did I screw up? 530, 560, 550, 590. No, I think I'm good. Okay, and then 500, 560 again. Not 56, 560, 440. Okay, and 300. Okay, now I got my data in there. Boom. Okay, so what I'm going to do now is I'm going to go to stat. Okay, and calc. Okay, stat calc. Okay, so how do I get my regression correlation coefficient for this guy? Okay, so on the calculator, okay, we're going to go to stat calc. Okay, this is on the TI 84. Okay, stat calc, and then I'm going to go down here to linear regression 4. Okay, that's going to be 4. Linear regression. Okay, linear regression. Okay, and I'm going to hit enter. Now, it's going to ask me, what's your X value? And I'm going to tell it, it's L1. My X value is L1. And then it's going to say, what's your Y value? And I'm like, my Y values, they're in L2. And they're like, oh, okay. And then we're just going to arrow all the way down. We don't care about the frequency of the list or store, and we're going to store this as regression equation. Awesome. That's great. Store that as the value. Perfect. We're going to hit calculate. Now, this comes up with an R value. Now, a lot of your calculators, who are those of you that are running calculators, it's not going to come up with the R. So let me show you, for those of you that it doesn't come up with the R. If it didn't come up with an R value here, I'm going to write down the R value first before I lose it. Okay, so for that one, it was 0.9746. Man, that is really close to 1. That is there's a really strong correlation. The closer it is to 1, the stronger it is. Okay, so that's really strong. Okay, so if you didn't get the R here at the very bottom, you just got A and B. Here's what you do. You go to second 0, okay, and it'll go to catalog. And you have to arrow all the way down, and you only have to do this once in your lifetime, okay, or the lifetime of the calculator. It'll remember how to do this. It'll remember that you put the settings on. And it's called diagnostic on. You want diagnostic turn on. Okay, right now it has diagnostics off. If it's a brand new calculator or you've never done this before, you want to turn diagnostic on. So I'm going to arrow down all the way to diagnostic on. Where's the D's? A lot of C's. Okay, there we go. And do you see that right there? Diagnostic on. And then you turn diagnostic on. Boom. And you hit enter and it's done. And it's done forever. You never have to do that again. So when you go back in and you do stat calc 4, okay, and you just hit enter. You just enter it all the way. It should come up with that correlation coefficient. Okay, it's called the correlation coefficient, or your R value. Okay, should come up with that value. Okay, and so we saw that the R was very strong for the data that we were given. Okay, what was the R value? The R correlation coefficient was equal to 0.9746. This is a very strong, what? It's a strong positive correlation. Okay, strong positive, strong. Okay. Okay, any questions on this before we moved on to 12.3? Okay, sounds good. Okay, let's talk about the regression equation. Okay. Use a regression equation to predict one variable given another. Okay, x versus y. Interpret the slope and the y-intercept. What's the slope and the y-intercept of a regression line in context? So we're going to figure out what these lines mean. Okay, predictor. Okay, terminology: predictor, explanatory variable, or independent variable. That's the x variable. Okay, the x variable is always the independent one. Okay. Okay, the response variable, or the dependent variable, that's the y variable. Okay, so think x independent, and that's always going to be the horizontal on a graph. Okay, that's your horizontal variable. And your y variable is your dependent variable, and that's always going to be vertical. Okay, that's always your vertical variable. Okay. Okay, so what is a regression line? Remember y equals, okay, mx plus b. Okay, y equals mx plus b. Okay, that's the slope and the y-intercept, right? So slope, the m was the slope, and the b was the y-intercept. Okay, you can think of b as where you start when x is 0. Okay, so when we're at the starting spot, you can think of b as your starting point. Because when you have your x-intercept, that's where you start. Okay, if you want things to be positive, and generally we want to talk about positive things. Okay, that would be your starting point. Okay, and then you just go up there, you go down from there. A regression line, also known as a least squares regression line, is a line that best fits the data in a scatter plot comparing two values. Okay? It is used to estimate the value of one variable, y, okay, given the x. So estimate y given x. Okay. The general form of the regression line of y on x is below. Y hat is equal to a plus bx. Now, I'm not going to use this one. I'm going to use y equals ax plus b. I'm just going to swap the a and the b. It's really the same. Okay, don't freak out about that too much. Okay, I just want it to correlate to what I'm doing on the calculator. Okay, the calculator reverses the a and b, and I don't want you to get confused. Just cross, I have to update this in the notes. Okay, so b is the y-intercept, a is the slope. Okay, b is the y-intercept, a is the slope. Okay, b is the y-intercept, a is the slope. So yeah, update that. I just want to switch a and b, otherwise it's going to get really confusing when I use the calculator. Okay, note the hat, okay, on the symbol. That means that this hat is a statistic. It's not a, okay, it's a statistic. The symbol means that the y value found is a predicted value, okay, of y rather than the observed true value. This hat symbol is very important in distinguishing the two, okay? We can use technology, okay, to find the least squares regression line, LSLR. I'm just going to call it the regression equation. Okay. Okay. First, enter the pair data into the two lists. Make sure that the order of data corresponds with each other. Okay. And then again, this is the intercept. We're going to call the intercept B. Okay. B. And we're going to call the slope A. So I don't know why these notes are not very consistent. I didn't write them. I stole them from my colleague. So I'll have to go back and update those. Okay. Okay, so let's do this on StatCrunch. Ooh. Okay, let's do this on StatCrunch. Let's find the regression and simple linear since we did the regression equation on the calculator before. Okay, we found that correlation coefficient, right? On the calculator. Let's do it on let's do the regression line for the McDonald's burgers. McDonald's sandwiches, I should say. They're not all burgers. Let's do that on StatCrunch. Okay. So let me open up StatCrunch real quick. Go away. Go away. There you go. Okay, let's go to statcrunch.com. Let's do this on StatCrunch real quick. What? To ensure, what? You don't know my country? What the heck, man? It's the USA, baby. US of A. Okay. Let's do this thing. Okay, so I'm going to go back to the McDonald's data that we have, and I'm gonna enter that 9, 13, 21, 30, 31, 31, 34, 25, 28, the 20, and 5. Okay. Okay, and then 260, 320, 420, 530, 560, 550, 590, 500, 560, 440, and 300. Okay. Okay. So first, let me show you how to get the correlation coefficient here. I'm going to go to stats, summary stats, and correlation. That's it. Stat, summary stats, and correlation. How are we going to get R? Okay, and it says select your columns. I'm going to select both of these with Shift. Okay, and I'm going to go to compute. Okay, and it says the correlation between column 1 and column 2 is 0.9746. Boom. That's the correlation coefficient. Now, what's the regression equation? Okay, let's do the regression equation in StatCrunch. Okay, so we're going to go to stat. Regression, where's regression? Okay, regression, and simple linear. Stat, simple linear, select your X variable. The X variable is var1. The Y variable is var2. Okay. Okay. And the graph will be a fitted line plot. That's fine. Okay, and let's calculate this out. Whoosh. Okay, and it says up here, we want to read the first part of this. The table is not too helpful, to be completely honest with you. Okay, what we're interested in is this guy here. This says that, oh, and this actually gives me the correlation coefficient. I didn't have to do that separately. That's nice. Okay, this says that var2 equals 193.85 plus 11.73 times var2. So let me explain what this means. Okay. Let me go back here to, so this is 193.85. So var2 was my y values, right? So var2 is y, and this var1 is x. var2 is y, and var1 is x. So 193.85 and 11.73, right? Okay, so for McDonald's, it was 193.85 plus 11.73. Okay, and var2 was y, that's my y hat, is equal to, okay, times my x value. My var1 was my x value. Those were my independent, and y hat is, okay, so what is my y-intercept? Well, that's b here. What's my x-intercept? That's a. So, okay, so if you want to write this in slope-intercept form, you would have to put the second term first. You could say 11.73x plus 193.85. Okay, so that would be the linear regression equation for, okay, for the McDonald's sandwiches. McDonald's sandwiches. Now, if we go back to the calculator, okay, how do we get the regression equation? It's the exact same way that I got the correlation coefficient, the same thing. So I'm going to go stat calc, and I'm going to go number 4 here, linear regression, and I'm going to go list 1, list 2, and then calculate, and it tells me, look, your slope A is 11.73. Your y-intercept B is 193.85. It's the exact same equation that we got in StatCrunch, which is good because it should be, because it's the exact same data. Okay. Okay. The R tells me how strong an association it is. The 11.73 tells me the slope. It's based on R. It's not R, but it's based on R. It's 11.73. What does that 11.73 mean? It means, okay, if we go back to the McDonald's, okay, the X values were the fat, right? The X values were the fat, and the Y values were the calories. Okay, so the X is the fat, Y value. So what is slope? Well, slope is the change in Y over the change in X. It's the Y's over the X's, right? Y over X. So it's the calories over the fat. Or we would say that there's an increase of about 12 calories or 11.73 calories. There's an increase, I'll write this as a sentence, 11.73 calories per gram of fat, per gram, okay? So an increase of 11.73 calories per gram of fat on average. That's what that slope is telling me, okay? Now, what is the y-intercept telling me? Well, in this case, the y-intercept is really not telling me much at all. Why? Because the y-intercept would be where I'm starting. And again, I'll go back to the very beginning, okay? It would be where I'm starting here, and it says that my starting point is about 193.85. And that says that if I have a sandwich with 0 grams of fat, then it's going to be about 193. Well, that all depends. I mean, that's not real specific. That depends on what type of sandwich it is. You know, if it's, maybe it's not even a sandwich. I mean, it says sandwiches, so it'd be a sandwich, but what constitutes a sandwich, right? Maybe this is, maybe it has nothing but, cucumbers in it, right? It's like it's cucumbers it's a lettuce wrapped cucumber sandwich. And you're like, well, that may not have a lot of calories. Okay, so it's the x-intercept is an estimate. At 0 grams of fat, the sandwich may be around 193 calories. So sometimes it's a good estimate, sometimes it's a bad estimate. Okay, so in this case, it's not great. It's okay. Okay, you certainly cannot estimate things outside your range of data. And I think that's the whole thing here. It's very hard to estimate things outside the range of data. Okay. Okay, so the y-intercept of 193.85, okay, describes the potential calories for a sandwich of 0 grams of fat. Okay, of 0 grams of fat. Grams of fat. Okay, so that's what that 193.85. It's the starting point. Okay, now could this ever go lower than 193? Well, I can't predict that, one, because we can't have negative calories, right? We can't have negative calories. We can't go lower than, we can't keep going. And we also can't have negative grams of fat. So if we start putting in negative numbers in there to try to get this thing to go lower, it's not going to work. Okay. Other software will look similar to StatCrunch, but the labels will look different, like the calculator, we're labeling y equals ax plus b. Okay, instead of labeling the row with intercept, sometimes the software calls it constant. Okay, instead of labeling the row with slope, the other software will list the name of the variable. It's fine, whatever. Okay, scuba divers. Let's do our scuba dive. Okay, scuba diving with Scuba Steve. Okay. Okay, scuba divers have a maximum dive time, times they cannot exceed when going different depths. Okay. The data in the table shows different depths with a maximum dive time in minutes. Okay. Use StatCrunch to find the least squares regression line, okay, the regression line, and predict the maximum dive time for 110 feet. Okay. So let's look at this. Okay. So as I go up in my feet in depth, or down, I guess, in my feet in depth, okay, as I go further below the water, what happens to the amount of air that I'm consuming? Well, I'm consuming a lot more air, which limits the amount of time that I can stay down there, right? Again, this is going to be an inverse relationship or a negative correlation. Why? Because as the feet goes up, the time goes down. Okay, because I use a lot more oxygen the further I go down, which means that I can only carry so much on my back. And so the time in which I can stay down there is extremely limited the further I go down. Okay, so up, down. So this is a negative, this should have a negative correlation. It should also have a negative slope. Okay, negative slope. Okay, so it should have a negative correlation, R, okay, correlation coefficient, R, and it should have a negative slope. Okay, if we do everything correctly. Okay, what would the graph of this look like real quick? Okay, if we just wanted to graph a little bit of this, okay? We're starting with the feet and then the dive time, right? So the feet go from 50, 60, 70, 80, 90, 100. And then what do the dive times go from? The dive times go from 80 to 22. So I'm going to go from 0 to 100, basically. So 0, and then maybe 20, 4 now. I got to put those closer together. I'm going to go by 20s. Maybe I won't go by 20s. Maybe I'll go by 30s. Okay, so 0, 30, 60, 90. Okay, so this is time in minutes. Nope. Oh no, we could because that only goes up to 80. So what am I doing? I could do 20s. Okay, 20, 40, 60, 80. There we go. 80, 60, 40, 20. This is in minutes, and this is in feet. Okay, so 50, we're at 80 minutes. Boom, nice. Okay, at 60, we're at 55 minutes. We dropped to 55 minutes. At 70, we're at 45 minutes. 70, 45 minutes. 80, we're at 35 minutes. Okay, 90, we're at 25 minutes. And 100, we're at 22 minutes. So, okay, so we can definitely see that there is a relationship here. Now, I don't know what the line of best fit is going to look like. It's probably, that's probably too high. 50 was at 80. Okay, maybe more like this. Okay, I don't know. It's going to be something like that. Okay, let's actually figure out what that is, and we'll talk about, okay, the residuals. Okay, so let me go to the calculator and let's put in our new stats. Okay. Okay, so I'm going to go stats and then I'm going to go edit. And I want list 1 to be my x values. That's going to be 50, 60, 70, 80, 90, and 100. Okay, I'm going to delete everything else. Okay. Okay, my y values are going to be 80, 55, oops, 55, 45, 35, 25, 22. Delete, delete, delete everything else. Okay, so we have these values in there. Okay. Okay, so I'm gonna get the regression equation for this. So let's get the regression equation. So how do we do that? Stat, okay, calc, and then number 4. Stat calc 4, boom, and then just hit enter until you hit calculate and then enter. And it says, okay, y equals negative 1.11, okay, x, negative 1.11x, plus b, which is 127.23. Okay, 127.23. So that's the regression equation that the calculator got. Now, the calculator will actually graph this for me. I'll show you how we could do that in a minute. It can graph the line for me, and it can show me how close I am to the data. So let's do that real quick. Okay, so the first thing I'm going to do is I want to plot the points. Okay, so I'm going to go to second, or plot the data, second, and then hit y equals. So second and then y equals, and that's stat plots. And I'm going to turn my first stat plots on. So I'm going to hit enter on the 1, enter. And I'm just going to hit that on, turn that on. And then I'm going to kind of arrow down to make sure that I have, yep, I want a dot plot. That's what I want. I want X to be list 1. That's correct. I want Y to be list 2. That's correct. I want the marks to be these open circles. That's correct. Okay. And then I could hit graph, but nothing shows up. It's kind of weird. Nothing is there. Why? Because my scale is off. Okay. So I need to have the correct scale to see my data. So I'm going to go to window, right next to y equals. I'm going to go to window, and I'm going to give it the correct scale. I want my x's to go from where to where? Well, I want them to go from about 50 to 100. So maybe I'll go a little bit lower just to get all the data points in. So we'll go from 40 to 110, and we'll go by a scale of 10. So that'll give me my divisions. Okay, I like to have anywhere between 8 and 10 little lines between my values. And then we're going to go from 0 to 80, or maybe 0 to 90 in my y values. 0 to 90 in my y values. And we'll go by a scale of 10 as well. Okay, and I'll just arrow down. Okay, once I get that in, I can just hit my graph again, go over and hit graph. Okay, and look, lo and behold, there are my points. Okay, that's my data. That's my data points. Now, Now I want to get my regression equation. Okay, I want to get the regression equation. Well, the calculator stored this equation that we did. It stored it already in the calculator. All I have to do is call it up. Okay, and so what I'm going to do is I'm going to go y equals, okay, hit the y equals button, not the stat plots, not second y equals, but just y equals. And I'm going to call up the regression equation and say, okay, bring up the regression equation for me. And the way I do that is I hit vars, okay, variables, not second vars like you're used to, but just vars. And I'm going to go to statistics. Okay, and then I'm going to go over here to equation, EQ, and it says regression equation 1. So I'm just going to hit the 1 for the regression equation, and that's going to give me, if I arrow over here, you'll see, it will give me the regression equation populated. There's my slope, negative 1.114, okay, x times x plus 127.23. Okay, this should actually be 24. Now, I didn't have to do it that way. I could just have typed it in, okay, as the equation that I'm boxing right there. I could have typed that into the calculator just as easily. Okay, it's just kind of nice. This one's a little bit more accurate and shows you that the calculator does store the regression equation there. Okay, if I wanted to clear it, I could just do negative 1.11. Okay, x is right below the mode key, x, and then plus 127.24. Okay, and then I'm going to graph that, hit graph, and look at that. That graphs the line of best fit. Okay, that graphs the line of best fit there. Okay, so that's my line of best fit. That's the regression equation line, okay? That's the slope and the y-intercept. Here's somebody's mic. Okay, so let's talk about the residuals. What does the residual mean? Well, the residual is how far away these points are from the line of best fit, because the line of best fit is the line of best fit. It best fits the data, but there still is differences between the points and the line. And it just says the residual tells us how far an observed y value is from the predicted y value. Okay, so we have observed and we have predicted, right? So the observed was, say for 50, this is the observed, right? For a depth of 50, we observed a max dive time of 80. Okay, so 50 feet, that's observed. Okay, the predicted is based on my line of best fit. This is the predicted amount. Okay, we're gonna, and the difference between those two, the difference between the observed and the predicted, okay, is what we call this residual amount. Okay, it's kind of like the error. If you think of the residual as the error amount, it's the error. It's the error from the observed to the line of best fit. Okay. Okay, example 1 continued says, okay, predict the maximum dive time for a depth of 60 feet. 60 feet. Well, how can I use the line of best fit to predict the dive time? Okay, so, well, what is the equation? What's the y? The y is the dive time, right? So y, which is dive time, is equal to negative 1.11 times x. And what's x? X is the depth plus, okay, 1.127.24. Okay, so what am I going to do? I'm going to plug in to my depth. I'm going to plug in 60. Okay, for my depth. Stop. Go away. Okay, I'm going to plug in 60 for my depth and then get a predicted dive time. Okay, so let's do that. So what's negative 1.11 times 60 plus 127.24? Okay, that's 60.64 or about an hour. Okay, so 60.64 minutes. Okay, or about an hour, about 1 hour. Okay, so if I'm at a depth of 60 feet, not 6 feet. If I'm at a depth of 60 feet, I can go, I have air to last me about an hour. Okay. What was the observed maximum dive time given in the data? The maximum dive time was 80. Okay, that was 80 feet. Okay, calculate the residual. Okay, so what would be the residual here? Oh, sorry, that was 80 minutes. The maximum was 80 minutes, right? What is the observed maximum dive time? Yeah, it was 80 minutes. Okay, so calculate the residual and then write a sentence. Okay, so what's the residual? Well, the depth was 50, right? So the depth was 50. So the observed depth of 50 gave me an observed dive time of 80 minutes. What would be the predicted? Okay, predicted depth of 50 is going to give me a predictive dive time of what? Well, here I have to calculate it. Okay, it's negative 1.11 times 50, times 50 plus 127.24, right? 24. Okay. So this should be my predicted dive time. This is the predicted dive time, which is equal to what? So let me steal this guy from above and just put in 50 instead of 60. Stop. Behave. Okay, so let's put in 50 instead of 60. Okay, and it says that it's about 71.74. So what's the residual? Well, the residual is the difference between the two. Okay, it's the observed minus the predicted. Okay, so the residual is the observed minus the predicted. So based on our equation, it's predicted that you would only have 71.4 minutes of air. Okay, the observed was that, no, you really have 80 minutes of air minus the predicted of 71.74 minutes of air, which is about an error of about, we'll say, 8 minutes. Okay, so that's my residual, is the error. Okay, which is good because it kind of errs on the side of caution rather than err on the side of, hazard. Okay, how do we interpret the slope? Okay. Okay, for each additional foot, okay, for each additional foot that we went down, okay, for each additional foot, and this was a decrease, right? What was the slope? The slope was negative 1.11, right? And that's feet per minute, right? Because it was the, look at the plot here. Yep, it's feet per minute. It's x over, sorry, it should be, sorry, other way around, minutes per feet. Negative 1.11 minutes per feet. That makes more sense. You're losing time every foot you go down, okay? So it is a negative slope. Okay, you're losing about a minute for every foot that you go down. For each additional foot, we predict a 1.11, okay, slope, okay, with the y unit. So what's the y unit here? 1.11 decrease, okay, decrease in minute, okay, about 1.1 minutes of decrease. Interpret the y-intercept. Okay, what about the y-intercept of this 127? What does the y-intercept mean here? 127, okay, about 127. Well, the x would be 0 there, right? If I plug in my 0, okay, into my equation, right? Y equals negative 1.11x plus 127.24, right? If I plug in 0 here for x, then this whole thing goes to 0. And so y would be equal to 1. What does that mean? It means that if I just snorkeled and didn't go very far, well, I didn't leave the surface, I could potentially, just use the breathing apparatus for 127 minutes, about 2 hours. That's what that means. We would predict to be, okay, 127 minutes, okay, or 127 minutes would be available when, okay, the feet, or the x variable, the feet, is 0. Okay, when we're 0 feet deep, we could go about 2 hours on our tanks. Okay, interpret the slope. We kind of just did this. Okay, interpret the slope and y-intercept in the context of the problem. Well, what's the slope? The slope is for each additional foot we dive, it decreases our time by 1.11 minutes. Okay, that's what the slope means. For each additional foot, think of it as like miles per hour, right? Miles per hour. Okay, that's a slope. So if you think of it like, 50 miles per 1 hour, okay, well, what would your slope be? Your slope would be 50. Here, it's 1.11 minutes, but it's a decrease, right? It's a decrease. That's why it's a negative slope. Negative slope. Okay, what about the y-intercept? Okay, the y-intercept, that's the max dive time if our depth is on the surface of the water and is about 2 hours. And it's about 2 hours. Okay. Okay, I'll stick around for the next hour to field questions on the homework. If you want to start working on the homework, otherwise you are free to go at this point.
Professor, I just wanted to ask you clarity on our final. Do we have a final test?
Yes, you do.
We do have a final test.
Yes.
And that'll be the last day of class, or how will that happen?
Yes, that will be the last day of class.
And it'll be based on all the things we've done from the beginning to the end, or will it just?
Yes. It is cumulative. It will be consist of 35 multiple choice questions.
Okay, thank you.
Welcome. Okay.
Is that the same thing? Oh, sorry. Is that the same thing as the take-home exam?
No,
Okay.
no, that's the chapter 12. That's just specifically for chapter 12.
Oh, I see.
Okay. There will be a final on June 4th during class.
Professor, do you think on the exam 3 you can make the correct answers available to view? Because right now I can't see it.
You can't view the correct answers,
Yes.
but you were able to do that on exam 2?
I didn't check after exam 2. I just know I can't do it with exam 3.
Oh, okay. Yeah, I'll see how that works in Canvas. I'll research that.
Thank you.
Sure. Okay. Let me just stop the recording real quick.